So right triangle, trigonometry. So given a right triangle these 6 trig functions are defined as, I'm sure this is familiar, hopefully. So, right, so Katoa. You guys remember that at some point? If not, that's okay. Talk about it right now. S would be, the so is sine, opposite over hypotenuse. Chi is cosine, adjacent over hypotenuse. C for cosine. Toa is the tangent, opposite over adjacent. And they will all be defined at an angle theta. So opposite, adjacent, and adjacent will determine on the location of the angle in question. So if I put the angle up top, then opposite is going to be down here. The angle somewhere else, opposite will be opposite to the angle theta. Okay. In general, usually we use this setup here, but it doesn't have to be this way. So here's a right triangle. If theta is here, opposite to the specific theta, opposite's over here. Right? Right there. Adjacent means right next to it. So adjacent is here. Then hypotenuse is always hypotenuse. That doesn't change. I mean, I could have the triangle facing a different way, but hypotenuse will be hypotenuse. Okay, so let's put it in words. Number 1, sine theta is equal to, I'm going to shorten it up, opposite over hypotenuse. That's what we meant by the so part. Okay. 2, and move that mouse pointer. It's kind of annoying. All right. Cosine theta. That will equal adjacent over hypotenuse. Tangent theta will equal opposite over adjacent. Now, if you want to memorize using the mnemonic here, go ahead. If you want to put this on your formula sheet, that's fine too. But I feel like after a while, if you don't already have it memorized, you will eventually. But again, I'm not going to force you to memorize anything. 4, 5, 6 will be the reciprocals. What is the reciprocal of sine? Reciprocal. Yeah. You flip it over. You remember? Yeah, it's either cosecant or secant. I believe, yeah, you're right. Cosecant theta is hypotenuse over opposite. So that means secant will be the reciprocal of cosine. So just flip it over. Cotangent, that one's the obvious one. Adjacent over opposite. This is pretty much the main thing we're going to need for the homework. So what they're going to do is give you triangles to solve. And you use these ideas to find the missing pieces. And then I think you can also use the formula from last time. Okay. But mainly these definitions. You guys okay on this page? Right. I'll try to pick examples from the homework so you have at least one of each type if I can. Example 1. Find the values of B and C given that A is equal to pi over 3. All right, so they give you a picture of the homework. I'll draw it over here, I guess. This is number 5. B is missing. C is missing. C will almost always be hypotenuse, if not H. A and B, lowercase a and B will be the other sides. Doesn't matter which, it's the same thing. Okay. When you're solving and you choose to call one side B and the other side is A, doesn't matter. But we have 2 missing sides, so we can't do Pythagorean theorem, right? Can't. But you use the definitions that help you out. So we know that this angle A is pi over 3. So let's, I don't know. I'm going to choose sine. Sine of pi over 3. What would that be equal to? Not on the unit circle, but by definition. Right, we said sine is opposite over hypotenuse, so what would you put? Yeah, I think it's going to be, so here's A. So opposite to the A in question, the angle, is 5. So opposite side over the hypotenuse. So given this, you can solve for C, right? Once you have the C, you can do Pythagorean if you want, or you could use another trig function that incorporates B, lowercase b. That makes sense? So at this point, you're just doing algebra, but the setup is what makes sense, is what's important. Does the setup make sense to you? Right. A is right here, and it's pi thirds. We define sine to be opposite over hypotenuse. So the location of angle of theta was here, opposites over here. Our location is there, so opposites now here, right? Okay, so solve for C. You can multiply both sides by C. It's one way to do it. C times sine of pi over 3 equal to C times 5 over C. Okay. So now I have C sine of pi thirds equal to 5. Divide that sine out, both sides. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . And we have solved for C. So side C, or the hypotenuse C, is equal to 5 over sine of pi thirds. What is sine of pi thirds on your unit circle? Pi thirds is what? 60 degrees, right? You don't have to have it memorized. I did say you should print it out or open it. You're not going to print it for the exams, and you have to memorize it. Yeah, that's right. So this will be 5 over square root 3 over 2. Okay. Although that looks super weird. So let's fix it. If you divide by a fraction, what happens? You remember? Dividing by fractions. This is the same thing. You divide by fractions, you flip it and multiply by fraction. Right? So you always flip this over, times the 5. I put the 5 over 1 so you can see it a little better. So this will become 2 times root 3 over root 3, which is 10 over root 3. If you're rusty on fractions, is this clear? Is that okay? Yeah, so whenever you're doing division by fractions or with fractions, let's say you have like a half divided by a third, right? That's the same as 1/2 over 1/3. But the rule is the same. The rule will be, I'll just put it down here for both. You keep the one you're dividing into the same. Whatever is the divisor, you flip it over and you multiply. It's always going to be that way. So whatever you're dividing by, which is this, right? In this case, this guy, you flip over, take the reciprocal, and you multiply straight across. Okay, that's what you always do with division of fractions. Once you get there, you gotta get rid of that square root. Any other questions on division? Okay. Let me know. 10 over root 3. Rationalize, you have to kind of square the bottom. In order to do so, you introduce root 3 over root 3, which is a form of 1. So I'm not, it's basically like I'm doing nothing, right? Kind of like cheating, I guess. 10 over 10 times root 3. This will be squared, becoming just a regular 3. I skipped a minor step there. Is this okay? So right here we are rationalizing the denominator. All this work here, we're to solve for C. That's it. And there's many ways you can solve for C. Whatever. Some of you might like to do like a cross multiplication. That's fine. You just have to imagine a 1 on the bottom. I mean, I don't care how you do these problems, as long as it's legit math and you show your work, it's fine. Okay. You do witchcraft and you get the answer by accident, that's going to be wrong. Okay. It's a difference between different methods and made up stuff. We've seen some weird stuff. It's just magically it works out. I'm like, you know what? I want to give it to you, but it's complete nonsense. That's cool in example 1. I don't feel bad about fraction steps. Feel free to ask anytime. I have people in Cal 2 that forget.
So for instance, if we split like the answer is 10 over the square root, would that be right? Or would you want us to always rationalize?
I mean, on an exam, I would take it. It's fine, but the homework may not. Okay. Homework's probably gonna make you do this. All right, so we got B. I forgot. We got C. I forgot about B. Hold on. So at this point, we could do the same stuff, or we can use Pythagorean. That's up to you. But I'm gonna use the same method again so we can get the practice, not because it's the easiest. Okay. So I have B down here. So you have all 6 trig functions to choose from. And we have C now. So what trig function would you choose that incorporates B? What do you think? Because when you're doing this on your own, you'll have to choose. Am I going to use? Because I chose sine, right? So that's going to be you choosing. What do you think? What's that? Oh, if you use sine, we'll end up with the same thing. Because sine is defined to be opposite over hypotenuse. So which one is defined to graph as B? What is B? You could do and
Can you do cosine of B?
yeah, tan will work. Tan will work because you don't need to see. So if you didn't have to see, you could do tan. Yeah, yeah, I think so. But if you have C, you can also use something else. So you have many options at this point. But if you were starting to solve B first, tan would be the only option. You see what I mean? Okay, so let's solve for B now. So tangent of A, which is pi thirds, is equal to opposite over adjacent. So opposite is 5, adjacent is B. So the work will be exactly the same. The only difference is tangent of pi thirds is some different number. Right? So multiply both sides by B, you'll get to here. The B's cancel, getting it to here. Divide both sides by tangent, and you get to here. I skipped the minor steps because it's the same thing as before. Oops. Okay, so at this point, what is tangent of pi thirds? Tan of 60, right? Tangent of 60. Same as sine of pi thirds over cosine of pi thirds. Just divide them out, and you'll have tangent. So that will be what you said sine earlier was. So cosine has to be the other one. So we divide these, same deal, right? Flip it over, just multiply across. You're gonna end up with this right here. this guy, after you do your algebra, you have a root 3 at the bottom. So just plug it in, use your circle that I gave that I posted. Okay. Just remember the definition of tangent. It's just sine over cosine, just divide the two. Divide the sine and the cosine. Is that clear? So the twos will cancel, leaving you with just this root 3. So at that point, I mean, it's good enough, but we have to rationalize. So that gets us to 5 root 3 over 3. If you square the bottom. So here is B. And here is C. That's all they asked for, right? Okay. Any questions on number 1? Is that okay? So let me know. If I make no sense, just tell me. Not a big deal. Let's do another one. Yeah, it's cool on this page. No rush. Which one?
Or the square. Oh, you just multiplied them, right?
This one here? Yeah, I was trying to cancel trying to square the bottom, but I can't just do one side, so I gotta do top and bottom to keep the balance. So square root 3 times square root 3 is square root of 9. Square root of 9 is 3. And then this just stays 5 times that. You can't do anything else with it. Okay. Any other questions, or you guys okay? So let me know. Example 2. So here they give you angles on different parts of the triangle. So suppose x is equal to 9, y is equal to 40, and z is equal to 41. So they give us this triangle. This is the one from the homework almost exactly. Theta is here. This is a phi, the line, the one with the line through it. Right, z, x, y. That's why it's the part A. They ask, what is sine of theta? It might help if we write these numbers, right? I don't know. Z is 41, y is 40, x is 9. So if we're talking about the theta, the location is here, right? So if I'm here, opposite is going to be 1. Jason is right here. Talking about phi, opposite is now down here. See how it depends on the location. Okay, so we're looking at the theta. Sine of theta is defined to be
Opposite.
Yeah, opposite over hypotenuse, so what's the answer? 40 over, yeah, hypotenuse over here, 41. Yes, that's a phi, lowercase phi, one of the Greek letters. Yeah, they tend to use Greek letters for all the angles most of the time in the book. So it's theta, lowercase phi. I don't know why they do that. It's just what they do. I think the sides they use English letters. Went around. In high level math, we run out of Greek letters, and we start using Hebrew letters. Okay. Cosine. Theta. Yeah, so adjacent, right? Over hypotenuse. Yeah, 9 over 41. Okay. C is tangent. What is tangent of theta? Yeah, so opposites over adjacent. Is that clear? All right. Now let's do feet. What is sine of phi? Yeah. 9 over 41. E is cosine. Cosine of phi. Yeah, so I'm right here, adjacent hypotenuse. And F is tangent of phi. Yeah, so 9 over 40. Not too bad, right? That makes sense. Any questions on example 2? Okay. You know. Let's do a couple more. And then we'll do some homework. So in the triangle, given, express x and y in terms So in the triangle given, express x and y in terms of trig ratios. Of the angle z. Okay. So they want us to take the x and y and represent them using the definitions of cosine, sine, whatever. All right. So basically choose a trig function and then solve for x. So choose one that incorporates x, but with respect to z. Okay, so if I want to represent y or solve for y, what trig function should we choose? Yeah, we should choose sine, right? So for y, what is sine of z equal to? Yeah, so opposite over the hypotenuse. So all they want you to do is solve for y, and that's it. And they told us to represent y in terms of trig ratios, given that angle z, using the angle. So multiply both sides by 28. Gives us y. That means y is equal to 28 sine of z. That's all they want. So I represented y using trig functions. So any question on that first step? Is that okay? So now, if I want to solve for x, what trig function should we choose? Yeah, I think cosine would be good. So cosine of z would equal to adjacent over hypotenuse. So what would be our cosine? Yeah, just x over 28. So just solve for x and you'll be done. Multiply both sides by 28. Which implies that x is equal to 28 cosine z. Whatever that is. We don't know what z is, we don't know what x is, but we can solve for it in general terms. Any question on number 3? Okay. Let's do 2 more examples and then we'll stop the lecture. You guys okay on this page? All right. Let's shorten this question. Given an ABC triangle solve I'm just say solve the triangle. The book has it, I think, too wordy. So here's the triangle. Here is A. Here is B. C will be the right angle. Lowercase a is right here. Lowercase b is there. Hypotenuse is equal to 2, which is lowercase c. So that the book also uses capital letters for angles. So lowercase will be sides, and I'm always going to write them opposite to their capital counterparts. So capital B, opposite side is little b. Capital A, etc. Capital C. Does that make sense? So just always write it that way when we're solving these. It'll be easier. They gave us the angles for A, which is 46, and angle B is 44, I think. Yeah. Wait, no, they didn't. Hold on. All they gave us was A. But we can solve for B. Pretty easily, right? So what I'm going to do is write all the information here. They gave us side C equal to 2. They gave me angle A. What else were we given? Yeah, we technically have that angle, right? For C. What's the angle? Yeah, so that's technically given, but may not be obvious. Is that all we got? Yeah, we got the little C, and that's it, right? And they're in degrees, so make sure we got all the degrees. We don't have any other sides, but capital B should be clear. We know that the total adds up to 180 degrees, correct? So that means that B would be equal to 180 minus all the other angles. Which is 44, right? So we have all the angles now. How would you find little a? What trig function and what angle would you choose? More than one way to set it up. Many ways. But just choose one. What do you think? Let's do I don't know, let's do A first. What would we choose? Well, which angle would you choose? 40. We can do 46 or 44, right? Doesn't matter. So you first choose one of those locations, and then choose sine, cosine, tangent. Pick one of those. So if we choose 46, now opposite is A, adjacent is B, hypotenuse doesn't change. So what trig function would we choose if we're choosing this angle? we choose sine, we'd have opposite over hypotenuse, so we could solve for a no problem, right? Yeah, that's a good idea. So sine of 46 will guarantee that I'm choosing a over the hypotenuse that is given. So in one algebra step, I should be able to find a. If you would have chose something else, it might have been a little more difficult, maybe a couple extra steps, nothing crazy. If you end up with two unknowns, that means you should choose a different trig function. Like if you would have chosen tangent 46, you'd have had a over b. And you can't do anything. You can't solve it. You know what I'm saying? So solve for a. Multiply both sides by 2. So a is equal to 2 sine 46. At this point, you have to use a calculator. Make sure it's in degrees. Any scientific will do. If you have one of these, make sure you go to mode first. Check if you're in degree. Yeah, we're good. Yeah. So about 1.44. I don't know what they asked us to round to. I forgot what the question said. 1.4387. Around 4 decimal places for no reason. Just because. I'm pretty sure they tell you 2 or 3 in the homework. Okay. So we got A. Now we need to solve for B. So what trig function should we choose to isolate little b? What do you think? Cosine of which angle? So we choose 46, we'll have b over 2, right? Yeah, that'll be the easiest choice. Good choice. So you could have b over 2. That'll be the exact same arithmetic here, same algebra. 2 on both sides. So now b is equal to cosine 46. Oops, times 2. So what is that as a decimal? 1.389? Sounds right. Yeah. 1.389 for consistency. Add 4 decimals. I'm boxing the ones that we solved for. So in the notes, we were given the rest and we found these. Okay. Any question on example 4? Is that all right? You see, once you get comfortable with the sides and definitions, it's not too bad. Just gotta remember or have them ready, the definitions. Okay, so you guys cool on 4? Now, there's a couple of word problems in the homework. I'm gonna delete, I think some of them. I think some are kind of weird. But I'll leave the ones I think are a little more chill. I'm gonna turn the page, is that fine? Okay, let me know. So last question for today. I think in the book it was a U-2 plane, the spy plane. I don't remember anything about this question, but maybe I changed it. I don't know how this is. But I'm gonna draw you a picture. Yeah, you know what? I think I remember what it was. So let's say you want to know the height of this building, okay? And you're standing 61 feet away. So you'll have to draw this out if they don't give you a picture. If they just give you a story, then you have to figure it out. So let's say you're chilling over here, just hanging out, 61 feet away. And when they say in the book or in the questions, the angle of elevation is something, that means you're looking upward. Okay, if they say depreciation and you're looking down. Does that make sense? So in this question, he's looking up at the top of the building from here with an angle of elevation of 45 degrees. Let's make it simple. And we want to know what is the height of the building, given the information. So if you're standing here and you look up, you say, okay, well, how tall is the building? So you can use your trig functions to find it. Okay. We'll call this X. No, I think surveyors use that little machine, right? Aim the angle, and they can figure out heights, distances pretty easily. So once you have this, choose the trig function that will help you out. We do not have hypotenuse, and we want to know opposite. Opposite to the only angle we were given. So which one would you choose? Yeah, tan would be the best because it incorporates the one we want to know over the only other thing we know, right? So you got this, kind of have to be strategic about it. Choose the angle or choose the function that will not give you two unknowns and will have the side you're looking for. So tangent of 45 would be equal to x over 61. The setup is the most important part. Does that make sense? If you got that, then you should be good at this point. So solve for x. Multiply both sides by 61 feet. So x would equal whatever that is. What is 61 times tan 45? Yeah. Because tangent 45 is 1. So it just so happens, this doesn't, rarely ever happens. But it just so happens that he's standing away the exact same distance of the height. That's just pure luck. Okay. I chose an easy question. Maybe I should have picked a weird angle. Like 67. I don't know. Anyway. Does the setup make sense to you? Is the question okay? Let me know. If it doesn't. Let's stop here. This won't as much time as I thought for homework.